Today I'll be explaining Section 5.1, Question 3 in the textbook Calculus Early Transcendentals 7th edition by James Stewart. Part A. Estimate the area under the graph of f of x equals cosine x from x equals 0 to x equals pi over 2 using 4 approximating rectangles and write endpoints. Sketch the graph and the rectangles. Is your estimate an underestimate or an overestimate? Here's the graph of cosine x. Areas outside of the intervals 0 to pi over 2 have been messily shaded in gray. Since the problem specifies that there should be 4 approximating rectangles, we know that the area between 0 and pi over 2 should be split into 4 equal sections. These sections will have a side length of pi over 2 divided by 4. This is because there are 4 rectangles, and pi over 2 is the total distance between 0 and pi over 2. Pi over 2 divided by 4 is equal to pi over 8. This is how we know that each of the 4 rectangles that are going to be drawn under the curve cosine of x will have a side length of pi over 8. So let's begin with the first rectangle. Our first rectangle will be at pi over 8. Reach up until the right endpoint touches the graph of cosine of x before coming over. Since we know that this value is pi over 8, we can begin constructing our area formula. For this formula, since every rectangle will have at least one side length of pi over 8, we're able to place this in the formula outside of a bigger parenthesis. Inside of these parentheses will be the additional side length for each of the rectangles, which varies. I will be color coding them based on which color I use to draw the rectangles. The first rectangle, which I've drawn in pink, will have one side length of pi over 8 and another side length of f of pi over 8. We'll be able to calculate this value later on our calculators. The second rectangle, which I've drawn in green, will have one side length of pi over 8 and a second side length of f of 2 pi over 8 because there are 2 intervals of pi over 8 before this rectangle meets the graph of cosine x. 2 pi over 8 is equal to pi over 4. The third rectangle will exist at 3 pi over 8 until it meets cosine x. The base side length of this rectangle will also be pi over 8. Once again, this rectangle will have a side length of pi over 8, as seen in our formula, and another side length of f of 3 pi over 8. Again, this is because we have 3 intervals of pi over 8 before we reach this x value, which is coming up to meet cosine x. Our final rectangle should exist with an x value of 4 pi over 8. This value, however, is equal to pi over 2. As we can see, having a right endpoint at pi over 2 would not create any rectangle at all, because this is an intercept point for our graph of cosine x. For this reason, we will not have a final value in our area formula for this particular approximation. This means that pi over 8 times f of pi over 8 plus f of pi over 4 plus f of 3 pi over 8 is our final area approximation for the graph of cosine x on the intervals 0 to pi over 2. Now we are able to plug in our area function into our calculators using the following procedure. Go to the y equals menu and enter cosine x as your y1 equation. Now we're able to set up our area formula by taking pi over 8 times alpha f4 y1 of pi over 8 plus alpha f4 y1 of pi over 4 plus alpha f4 y1 of alpha f1 3 pi over 8, which is equal to about 0.79. Since part A of the original question asked us whether our estimate is an underestimate or an overestimate, we can now consider that portion of the problem. Since we used right endpoints, each of our rectangles falls short of the original curve cosine of x. This missing area causes our estimate to be an underestimate. Part B of the question requires us to repeat part A using left endpoints. Again, here's the graph of cosine x. Since we still have 4 rectangles, and they each have equal subintervals, then we're going to know that each of these intervals is once again going to be pi over 8. The only real difference between our rectangles this time compared to our last problem will be where they meet the graph of cosine of x. For example, in our last problem, our first rectangle went over pi over 8 and up until it hit cosine of x. Our new rectangle, however, will reach up to meet cosine x before coming over pi over 8. This is because the left endpoint creates a rectangle that reaches up over our curve. Our area formula will be very similar, but we must take into account that these rectangles will have different side lengths than our original problem. Our area equation will look like area is equal to pi over 8 times, now this can't be f of pi over 8 like the last problem, because f of pi over 8 would stop right here. Since we used a left endpoint, we know that our other side length will actually be equal to f of 0. We'll now be able to add this to a second rectangle, which I will use green, is going to reach all the way up to cosine x. This rectangle meets the x-axis at pi over 4. However, its side length will be where it met the first rectangle, which was actually at pi over 8. So f of pi over 8 will determine the side length of the second rectangle. The third rectangle will come up from pi over 4 until it meets cosine x. Come over to 3 pi over 8. So this will be f of pi over 4 and the final rectangle will come up until it meets cosine of x and come over until pi over 2, giving it a side length of f of 3 pi over 8. We will plug this equation into our calculators using the same procedure as before. First, open your y equals menu and make sure cosine of x is listed as your y1 value. Now you'll be able to enter your area equation into the calculator, starting with pi over 8 multiplied by alpha of 4 y1 of 0 plus alpha of 4 y1 of pi over 8 plus alpha of 4 y1 of pi over 4 plus y1 of 3 pi over 8. Which is approximately 1.183, which will be the area under the curve cosine of x from 0 to pi over 2. With this variation of the problem, it is safe to assume that our estimate was an overestimate because each of these rectangles comes up over the graph of cosine of x, creating excess area in our final product. We can check our answers for the over and under estimates by realizing that our final answer of 1.183 is significantly larger than our last problem where we got an answer of 0.79.